Hello friends, myself Shriranga Korde. Up to now we have seen working of for loop. So now in this we are going to see the usage of for loop to solve some problem. Now what is that problem? The problem is in a loop it keeps on continuing as long as the final end condition will meet. However, many times you have a requirement, how do you stop in between for a particular condition? Now, what I am trying to tell, is it very complicated? No, it's not. Why? Because when you drive a car or when you drive a two-wheeler, then typically you have a tendency to stop in between, and the action that you typically do to stop is braking or brake. That means, like, if I am driving a car and I want to purchase some items from a shop, then what will I do is I will slow down my car, I will stop my car there. That means I am going to brake. That particular braking action will happen. I'll basically go to that shop, buy the things, and once again I will proceed forward. So on the similar lines, here if I want to brake in between for a particular condition, then how do I do that? And that is what we will basically learn. So when I say brake, so brake is basically a keyword which is predefined as part of C language, and we are going to make use of that. So let's see it in action. So how am I going to use a brake statement or a brake keyword? So let us say that I am basically written a loop, and I want to basically just make a sum of all the numbers, okay, and I want to stop when that sum basically exceeds a particular value. So if that is the case, then I should be able to stop that particular loop in between, and it should not proceed till the end. Why? Because my value or my sum has reached. So let's see it in action. So what I can do is I can have int I, which can be a variable, then I will say sum, which is a temporary variable to do sum. I will initialize it to 0. Then I will write a for loop and say I will start with I is equal to 0, and I will put here I is less than, say, 50, okay, some little bit larger number, and I am going to increment it, okay. Then I want to basically do the sum. So what will I do? Sum is equal to sum plus I. Now if this code would have been something like this, and here I want to print the sum, that means here, so I will just say sum I and sum, and then here I can have percentage d, maybe I'll give backslash n, and then I can print I and I can print sum, okay. So if I now just execute this code, so what will I get? I will get I value is 50 and the sum value is 1225. Why? Because it completed the loop. I started with I is equal to 0. It will go till I is 49, and then when it reaches I plus plus, that means 50, it will come out of the loop. So loop will end, and because of that I value, it has printed 50, and the sum, whatever the sum of 0 plus 1 plus 2 till 49 is essentially 1225, okay. So now, however, now my requirement is, if such a loop is written, I want to stop this loop when say sum basically reaches 100, okay. Then how do I do that? And essentially I want to know with how many numbers my sum will reach 100. That means 0 plus 1 plus 2 plus 3, till what value, or till what, if I keep on doing, then till what it basically will reach 100 or more than 100. So if I want to do that, then essentially the sum is the rather the break is the correct keyword. So what should I do here? So sum I am going to calculate. Obviously I have told you, now I am going to put condition sum greater than, say, 100. Okay, that means the sooner it reaches 100, it should come out of the loop. Now if I basically don't do anything like this, okay, if sum is greater than 100, then what should I do? I will simply print here, say, percentage d, and I'll, for the time being, I'll simply print here sum, okay. Now why? Because if the sum is greater than 100, then basically what is happening, I don't want to continue further, I want to stop, okay. Now if I do that, then what will happen? If sum is greater than 100, it will print sum. Okay, but then it will keep on continuing all the loop. That is what I don't want. What I want is I should not continue. I should stop when the sum reaches 100. And then the sooner you have a break statement. So this is that break statement. Break statement. Okay, so the moment sum goes beyond 100, then this loop breaks. That means this break is going to take out of this loop, which is a for loop, and then you are going to have for printf, which is essentially going to print I and the value of sum, which is what we will see. So let's see now this in working. So let me just run this file. Now you will see this. Okay, so I is 14 and the sum value is 105. Why? Because it is keep on adding and it has ended, and when it has ended, that means the moment it exceeded 100, it didn't continue, and here you will see I is only 14, not like the one previous we have seen I was 50. Let me once again run this code. Okay, and let me change this to say only 25, and I want to check 0 plus 1 plus 2 till what it exceeds 25 value. Okay, so that means I will basically once again run it and I will know the answer now. So you will see I and sum. So I is 7. That means the sooner I becomes 7, that means at 6, and then sooner it becomes 7, that means for I is equal to 7, it goes beyond 25, and that's why it comes out of the loop, and that's why you see I not as 50 the way in which we have seen first time, but you see the value of I, which is essentially intermediate or in between, the sooner it meets our requirement. That's the important point, and that's the way typically the break statement works. Now, having understood this working of break statement, we can now see its usage. Say if I want to find out whether a number is a prime number or not. That's a very good use case. Why? Because now what is a prime number? The prime number is essentially a number which is divided by 1 or the same by itself. So example is say 13. So 13 is divisible by 1 because every number is divisible by 1 and no other number can divide 13. So that means only 13 can divide 13. That's it. That means now, but how do I check? Because if somebody gives me a number as an input and asks me whether is it a prime number or not, then how do I do? So essentially I will have to keep on checking till n minus 1. That means if the input is say 11, then I need to check till 10. If the input number is 13, then I essentially need to check till 12. Then only I can say confidently that the number is an even number. Otherwise, it's not a even number. Suppose if somebody enters say 24, then the 2, I will start dividing it from 2. So 2 itself divides 24. So definitely 24 is not a prime number. But if it is 23, then I will check, okay, 2 can 2 divide? No, 2 cannot divide. Then can 3 divide? No, 3 cannot divide. So that way I will keep on doing till 22. Assuming that the number or whatever the number I enter is a prime, that means it will go on till n minus 1, that means the last, that means the number that is entered till minus 1. So now instead of just talking about this logic, we can convert it into the code and let's see how it works. Okay, so I have just kept it ready sort of. So here there is a number we will say, and then we can use I, and then I will tell you why I kept it I. Then we are asking a user to enter a number. So user will enter a number and then we will just do a scanf on this. Then after this I can write a for loop. Okay, so I can do for loop and I will start dividing the number by from 2. That's why I am using this I. Okay, so I will have a loop and then I will say I less than equal to num number minus 1, or I could have done I less than num. That is also okay. Here I am using equal to, so I could have simply said less than num, then I don't have to do minus 1. Okay, and then here I will just say I plus plus. Okay, and then in the curly bracket, basically now what will I do is I will check whether the remainder is 0 or not. So I will use this technique. If num of I is equal to 0. Okay, and in that case what will I do? I will basically use a if statement, and then here then I can use a if statement and I will say printf not prime, not prime number. Why? Because it is divisible. The sooner number is divisible by 2 or any number for that matter, it is divisible from, because we are starting from 2 and we are basically incrementing I. So if it is divisible, that means it's not a prime number. Okay, then in that case I don't need to continue. Suppose if someone enters, let's say the same example that I took, 24, then 24 is divisible by 2, then I don't need to keep on checking whether 24 is divisible by 3. Why? Because anyway 2 has divided it, so there is no point in proceeding forward. So I will simply say break. Okay, now if I just break it, then I will here, but however when the loop completes, that means suppose if I have entered say 13, if I have entered 13, then what will happen? I will start dividing from 2 and it will keep on going till 11, sorry, it will keep on going till 12. That means now the loop has ended and then once again it will come. So if it comes out of the loop, then I can very easily say it's a prime number. Okay, I can very easily say here printf it's a prime number. Okay, now what is the issue in this? If I just write it like this, if I write it like this, then I do not know whether the this statement is printed because I have exited the loop in between, that means because of break, or has it completed the complete iteration and genuinely it's a prime number. So I do not know. So what will happen when the number is not a prime? Suppose if it is 24, or let's say if it is say any other number, let's say 39, then if I am dividing it by say 2, then 2, obviously 2 will not divide, but 3 will do. That means 2 has not worked, but 3 it will get divided, and then what will happen? It will break. So because of that, it will print a message not a prime number, as well as it will print a message prime number. So that is not correct. Why? Because then it's a complete wrong message that you are trying to print. That means you need to solve this problem. So how can you solve? You can use either, the trick is either you can check the value of I, and if the value of I is number, because when I plus plus will happen, essentially it will be number. Okay, suppose if it is 13, then it will divide it till 12, and then by the time it comes out, I plus plus would have happened, it would have stopped, and then it will be 13. So that is one way. That means you can have a check here by doing if I is equal to num. So this is one way to solve this problem. Okay, so I can have if I is equal to num, I can do that. But many people find this way of solving little complicated because they can't appreciate what I'm doing. So simple technique can be, I can have a variable called as say flag is equal to say 0. I will do it, and then I will basically first flash a message, then I will make it flag is equal to 1. Okay, and then anyway it is going to break, so I can say do it here if flag is equal to 1, then only basically, or I will say flag not equal to 1. Okay, because here the flag would have happened 1, then only if the flag is not equal to 1, then only we will basically say, or you can say flag is equal to 0. So the either way we can check the same condition, flag is equal to 0, or we can say flag not equal to 1, either way. So simple case could be, it could be equal to 0. So if flag value doesn't change, that means this portion has not executed, the flag has not become 1, and then we can peacefully say it's a prime number. So this is simple, many people understand it using flag, so I have done it, but if elegant way is to handle it using I is equal to num, so same thing can happen. So let me just now compile this and run this code. Okay, so I will enter a number, say for example I will enter 12. So it is going to say not a prime number, that is correct. Okay, because flag has become 1, it got divided by whatever the value. So let's run it once again. Now I will enter say 13. So it's a prime number, that is correct. I can run it once again. So let me enter here 23. Then it's a prime number. Then I can try running it with say 11. So it's a prime number. Let's try it last time. So let's say 36 or let's say 35. So it's not a prime number. Why? Because it is divisible by 5. First one, 2, 3, 4, 5. So that's the way typically you solve this problem, and we have used break here very efficiently, very elegantly, and then you made use of the flag, and then you told whether it is a prime number or not. I hope you like this video. Thank you.